Okay, should I start?
Yeah.
Okay, good afternoon, everybody. My name is Khaled. I'm the Worldwide University Program Manager at ARM, based in Cambridge. It's my pleasure to be with you today. And I'll want to spend a few minutes talking to you about the mbed platform. So how many of you know about ARM? The back? Okay. So I thought, usually when I give these talks, some people, don't know about ARM because it is an IP company, so you don't see it, in your face in the products. But it is a company now that is behind 95% of the processors that power mobile phones. You can see ARM processors really everywhere if you dig deep enough. So it's a British company. It was founded in 1990 in Cambridge. It spun out after a company called Acorn Computers, which was behind the BBC Micro in the 80s, and with an initial funding from Apple, Acorn, and VLSI. And now, obviously, it's a FTSE 100 company. It's valued at around 15 billion pounds. What it does, ARM basically designs a range of RISC processor cores, so low power, very efficient processor cores. The thing that is important here to remember is that ARM doesn't fabricate silicon. So we don't fabricate silicon. We design processors. So we have an IP. Think of it as VHDL or Verilog. That number of licensees license from us for a fee, and then for each chip that they sell, we get a royalty, a small royalty, a few percentages, right? So that's how we scale up, while actually sharing the pie with a large number of licensees. When it started, that was a very avant-garde business model, and it has proven to be successful. I would argue personally that the reason why we have all these wonderful phones, with all these capabilities at a very low price, compared to where we were before, it's because of this network model. It's not just ARM. It's a huge ecosystem of players. No one single player does the whole thing. We specialize in something that we are good at, which is the design of the processors and the IP. And then we license this, and we work with a number of licensees, and it goes all the way to OEMs, etc. That's why we are here with IBM. So we are working with IBM, and I think you will see some, or you have already seen some demos on how we are working very closely to make our microcontrollers or processor cores that power the microcontrollers talk to each other and talk through the cloud. So we license this to several players, dozens of players, who fabricate and sell customers, and then these silicon partners, then they sell to OEMs, and OEMs build products that we have, that we use, that consumers use. This is the barn in Cambridge where it all started with 12 people in 1990. Now we have just over 3,000 employees worldwide. So in the grand scheme of things, it's not a huge company, but in terms of its impact, it's with the ecosystem, is actually I think it's responsible for much more than 50%, maybe 70, 80% of the silicon, the ecosystem itself, or the silicon ecosystem. Right, so our business model is that, think of us basically as the R&D lab of the ecosystem. We research and develop a product, we incur this cost ourselves, then we license this to a number of players, and that's when we start bringing the money. So we take the risk at the beginning to develop a new product, working with partners. So we see what's going to happen 2-3 years down the line, and we develop processors and technologies in partnership with partners, and we incur the cost here in the first 2 to 3 years. Then we license this to a number of partners who will actually develop solutions that will start selling 2-3 years down the line, but for a long period of time, for 20 years plus. So we get our initial return in the license fee, usually a one-off fee, or maybe spread over a few years. But then the sustainable money comes afterwards. For each chip that they actually sell, we get a percentage. And typically, this is few percentages. And so everybody wins. So we get money out of licensing and royalty as well. And that's the sustainability of the model. So if you look at our income, for example, our revenue, it's actually just over $1 billion now. So in grand scheme of things, if you compare it to other companies, it's actually quite small, but we are in a way guaranteed income for years and years to come through this royalty model, right? So it's a sustainable model. That's why the price to earning ratio is quite high at ARM. The company is valued at, very, very high compared to its revenues. So it's a very sustainable business model. And as I said, you could look at it as we are an outsourced R&D of the whole ecosystem, right? So instead of them doing the R&D themselves and building their own processors, each one of them reinventing the wheel, right? They share what is standard. So they take it from us in return for a small percentage, and then they compete in the differentiation, in what the secret sauce that they add into it, right? Rather than reinventing the wheel, they take that thing from us. And by being able to license the same technology to hundreds of, if not over 1,000 licensees now, we can sell these things at a lower price, so everybody wins, right? So that's the key of the ARM business model. That's why maybe you don't see us in the product, but deep inside we are there, right? Where there are several chips on mobile phones, in cars now. You might get 20 or ARM-based processors in cars now, increasingly with the infotainment, etc. So we just crossed the ecosystem. We just crossed the 50 billion chip out there. So that's a cumulative thing. It's about 25% growth over the last 5 years. So this is just to give you an idea about what the company does, because a lot of people actually don't realize the business model of ARM. So what do we produce? We produce processors. That's our bread and butter. System level IP, data engines, fabric, 3D graphics as well. So produce GPUs as well for mobile phones, the Mali GPU. We also produce physical libraries. So instead of selling the IP as a logic description, we can also sell a physical layout, so optimized for specific node. That's also a lot of companies in the Far East, for example, for very fast time to market, they like to get the full laid out hard macro so that they can add their own stuff very quickly. And that's why you're seeing all these new products, I would argue, very, very quickly. It's because of this sophisticated value chain, right? There are many, many players in the value chain. No one single player can do everything. What we produce as well is software IP increasingly. So you are in mixing computer science and EE, so software, as usually the case, hardware comes out first and then software becomes the most important thing. And we are seeing that even in embedded things, software is becoming much bigger. And I think this year was the first time we had more software engineers than hardware engineers at ARM. Typically it's a hardware company, but this year the balance has shifted towards software, because hardware on its own, that's nothing, right? What gives it teeth is software. And software is becoming much more complex. What we used to think as embedded software is nothing now. We have embedded operating systems, etc., on even this tiniest of microcontrollers. Development tools as well. We have to enable our ecosystem to develop applications. So we have development tools. And we have obviously a huge connected community of, as I said, over 1,000 of licensees. And IBM is one of our partners. I'm glad to team up with them in this dawn of the IoT, which everybody recognizes will revolutionize the way we do things. It has a huge impact on our lives, and we haven't seen anything yet. And I would argue, I spoke to Paul several weeks ago, that a lot of the innovations will come from you guys. I think a lot of things are being standardized. You've seen some of these innovations in terms of software, in terms of hardware as well. There's a lot of choice at very low cost. The problem solving now is the differentiator, and a lot of this will come from you guys. Okay. So the main ARM cores are Cortex M, R, and A, just for your information. So it's very easy to remember, A, R, M. A, think of it as a application. So these are processors that go into mobile phones, into laptops, into set-top boxes, into servers, increasingly servers as well, into the cloud as well. There are 64-bit ARM-based processors now that are shipping at a fraction of the cost of the incumbent. And that is a major area of expansion at ARM. So R, think of it as real-time. So these are deeply embedded processors where reliability is extremely important, and where also real-time processing is very important. You need to know that if there is an interrupt, you should be able to service it within few clock cycles, right? If you're doing, maybe controlling the brake system of a car, you can't, play games with that. If there is an interrupt, then you have to be ensured that you can respond to it within a certain number of cycles. So reliability and determinism is very important. So we call this the hidden architecture, because you tend to find it deeply embedded in hard drives and cars, etc. And the Cortex M, which are microcontrollers, And these are, you find them in consumer, embedded systems. So you find them in telemetry, in all sorts of sensors, in health appliances, in wearables as well. And inside each of these families or series, you find different products. So for example, in the Cortex M, you start with the M0, which is extremely optimized. Its smallest configuration is 12,000 gates. Microwatts per megahertz, extremely tiny, and you could embed it into clothes and things like that. And you can go until the M7. The M7 is a DSP processor, really. It has huge DSP capabilities. And in between, you've got the M3, the M4, and there are some kits here that you can have a look at. So these are, the main ARM Cortex, the core series, but obviously there are others in terms of graphics with the Mali series, and we are expanding into IP and software as well. So the ARM ecosystem, and I insist on the word ecosystem because ARM on its own, as I say, is small, but the ecosystem is responsible for much of the electronics industry. You can find, I think somebody said 70% of all the electronics that you find are touched by an ARM product. So the range of it is quite huge, from wearables on the one end to, as I said, servers that are shipping now, 64-bit ARM-based servers, and anything that is in between. Okay, so that's just a general introduction to ARM, the business model, what do we do, and our main products. So I wanted to spend a few minutes talking about the mbed, which is relevant to what you guys are doing. So what is mbed? Mbed is a platform used for easy prototyping, and you're beginning to see the theme of, this morning is all about, rapid prototyping. We don't want to reinvent the wheel, right? Because the key to differentiation is the problem solving. The ecosystem as a whole is building tools that allow you to build systems at a very high level. We don't want you to go into the low-level details of how an interrupt is serviced, etc. We can abstract this away for you and give you APIs, high-level APIs that allow you to be more productive. And you've seen from the IBM guys this morning a variety of tools. The Node-RED one is magnificent, isn't it? I mean, it's just wonderful to be able to build this kind of application at that high level. So on the Node side as well, so ARM contribution to abstracting away all of the details of the processor or the microcontroller details is through this API, which we call mbed. So it's both software and hardware. So it's open software libraries that are based C++, so you can deal with objects rather than working with at the low level, at the addresses and bits and things like that. And it has also open hardware design. So in theory, or in practice even, you take any mbed microcontroller, whether it's based on Cortex M0 or 4 or 3 or 7, and you can use exactly the same program to the same kind of API to program it. And you can interchange these things very easily. For example, you start with something that is very powerful to start with, then you start maybe looking at reducing the cost, and maybe you move down into a cheaper microcontroller, right? And you could use exactly the same code to do that. So that's very important. Interoperability is very important, yes.
So could I also change hardware vendors? So for instance, I start out on a Samsung platform, and then after a while I decide, oh, I want to go with a...
If they are mbed compatible, yes. Yeah. So there is a Freescale platform here, Cortex M4 based, which is mbed enabled, and we have another Nordic Cortex M0 based. It's exactly the same. You could use, obviously there are peripherals that exist here or there, but from an API point of view, it's exactly the same. That's the beauty of it. So you can interchange these things very easily. In fact, we adopted the same thing in teaching materials, because I run the Worldwide University Program, so we built education kits, full actually curriculum, modules, courses with labs, etc. But we could plug in these boards interchangeably. So we have an IoT kit, an education kit, which is a set of modules with labs, etc., that we are given to professors to build the IoT courses. I think we have set up dozens of these since we launched it in January. And that was the first one. Version was based on Nordic microcontroller, which is Cortex M0. And we are about to port it to a Nucleo board from ST, which is mbed enabled as well, Freescale K64, and the PSOC 4 as well from Cypress. The changes are very, very minimal. Yeah, cool. Absolutely.
Excellent.
So that's the open hardware design. And then you've got open online tools for professional rapid prototyping. So it's free online compiler You could go in, set up an account, and start. You don't need anything, basically, just an internet connection and a USB connection for your mbed platform. So it's based on C, C++. So there is an SDK, which is standard and open source, and there is an HDK, which tells you how to build mbed platform. So anybody actually can take that reference design and build an mbed kit if they want to. Basically, it tells you how to build the hardware. It's really a debug interface with the tools. It's based on a standard debug interface called SpaceHack that allows you to talk using a standard debugger to talk to any mbed microcontroller. And those of us who have worked on an embedded system programming know the difficulty in debugging these things, because everyone has its own standard, etc. With this one, we want to put some order into it, certainly with the Cortex M-based microcontroller. And there is obviously integrated IDE, which is online, that allows you to do that. There's a huge amount of code that is available. I think there is a community of, I think it's 1 million projects are open there, so you could actually download existing code, for example, I don't know, interfacing with Bluetooth LE or GPS or something like that. You can use code that is already there. It's community-based, so you don't have to reinvent the wheel. So the SDK, as I said, is a set of software libraries, and you've got a lot of, as I said, a lot of utilities there. You've got RTOS enablement as well, so you could do real-time processing as well, using some high-level functions for that. And you've got a cookbook with hundreds of reusable peripheral modules, so shields, plug-in shields that you can add into it. A lot of them are supported in mbed, and you could also export the actual mbed projects into some other tools, professional tools such as Kyle or CodeRed or Code Sorcery or others as well. So you are not constrained to that free online tool. You could export it to whatever tool you are using as well. So the hardware development kit, as I said, the key for it here is this debug interface here. And so it's implemented, this debug API is implemented on a Cortex M microcontroller. And basically there is a reference design here, so you can build a PCB based on this one. So it's actually open source. The benefit of having HDK is that anybody can clone mbed boards using this reference design. You can build your own, and the SimSysDAP API is available. You can download it into this, and you can use any of the standard tools to talk to the microcontroller and debug it that way. Okay, the integrated development environment is online, and you see here the projects and stuff. Sean, who's here at the front with Joanne. I think they showed you some of you. So there is a demo up there. You could have a look at it. You can set up. I was talking to John earlier. You can set up a project and do your first Hello World. I did it within 2 minutes before I knew about the mbed. So I knew nothing about it. I joined ARM 2 years ago. I used to be a university professor before. And one of the first things that I did when I joined is somebody from the mbed team introduced me, gave me a USB microcontroller and said, here is I think a small sheet. And he said, write your first Hello World. And it took me 2 minutes to do that. So you can get up and running extremely quickly and run some applications very quickly. And certainly that's why we are here, really, to help you out in later in the afternoon if you want to experiment with that. So examples of mbed platform, it's a huge ecosystem. And that's, so you've got this LPC 1768 from NXP, you've got another one from NXP, Freescale, other one from NXP, etc. The ones that we have here is Freescale K64F, which is Cortex M4. It's quite capable. It can do a lot of DSP, real-time, actually audio processing. It can do FFTs, all sorts of things. So it has floating point unit. And we have a low-power version, which is from a different vendor, Nordic, which is Cortex M0, based on the smallest processor core from ARM. So you've got the choice, and that's the beauty of it. So you can start developing on one platform and then migrate to another platform later on, or build your own. You can start with a development board like that, and then strip away the things that you don't need. For example, some people take the debug interface out. Once it's working and it's fine, you take that debug interface out of the system just to reduce the BOM, reduce the cost, and reduce the area. So it's quite a big and sophisticated ecosystem, and it gives you choice. Most of these boards are sub $20, $20 or $30. So some of them cost $10. The Nucleo F4 costs $10. Of course, you might add other peripherals to it, but some of them come with a lot of sensors already, temperature sensor, and you can add other sensors as well, humidity, etc., in a very seamless way. And that's the beauty of this whole platform. And that's my talk. Thank you for listening. I look forward to talking to you maybe in the afternoon on the technical side. Thank you.